Hello, this is what we're going to make today. It's a simple point-and-click movement system using the navigation components that Unity already has. So let's get started. First, let's see the elements in the scene. We have the directional light, we have a terrain, we're going to be moving our units on. And in this case, the terrain is just a plane, a big plane with a grass texture. Then we have the various obstacles that are just meshes with colliders, nothing special. And then we have the camera pivot. The camera pivot is just an object with a little script that has the main camera attached to it. This little object named camera pivot will be the one that's going to follow the units when they move around the terrain. The next thing in our scene is the unit. This little capsule is going to be our little soldier or whatever that is going to be moving when we click on the terrain. So what does he have? He has a little pyramid. This is here just to see where he is looking at, the direction he is looking at. And the last element in the scene is this pointer that is just a sprite with a sphere collider and another script. And by the way, the unit has a lot of components, nothing special, just a transform, of course, a capsule mesh filter, a capsule collider, a mesh render, the navigation mesh agent, which is the component that will allow the unit to move around on the navigation mesh, and a rigid body, and two scripts that will allow us to move the unit around. So the next thing we have to do, or well, the first thing we have to do to use the navigation utilities that Unity offers is to make a navigation mesh. To do so, we need to go to the navigation window, here, navigation, and here I have it already opened in here. And to set the blue area, which is the navigation mesh, we need to select an object, the one that we want to be the terrain in our game, and with it selected, we need to click on bake. Let's do this. Let's clear the navigation mesh that I already have, and we'll select the terrain and click on the navigation window and then bake. And of course I need to set navigation static because this object is not going to move. And now I click bake and I get my navigation mesh. On this part, on the bake, we have all the little variables that we can tweak and we can manipulate in order to modify how the navigation mesh is going to be made. And we can also divide it in areas that are kind of like layers of the navigation mesh. Anyway, this thing is really useful and it's really simple to use. You saw what I have to do, just set the mesh, bake it, and the navigation agents are ready to move around the navigation mesh with obstacle avoidance and that kind of things that you expect from artificial intelligence algorithms like the A-star and that sort of stuff. I mean, our units are going to move in a smart way. They're going to try to look for the shortest path to where we want them to move and without crashing into obstacles. So as you can see, the camera follows the unit around when it moves. So let's check that's the first of 4 scripts that this system is going to use. It's really basic. Let's take a look at it. This is the camera movement script. It just has 2 variables, a reference to the transform of the unit that it is going to follow, and a speed for the speed is going to follow the speed at which it is going to follow the unit around. And this is it, just a line of code in the update function that updates the position of the camera pivot. And like the main camera is a child of the camera pivot, when this moves, the main camera is gonna move with it. Why do we do this instead of just setting the camera as a child of our unit? Is because doing it like this prevents the camera from turning around when the unit turns around. So this only follows the position of the unit and not its rotation. It's a simple way to do it, and as you can see, it's just a line of code. Here we can see the camera movement script attached to the camera pivot, and its variables is 6 on the speed and the reference to the transform of the unit that it's going to be following here in the variable here1. The next script that we are going to be using or showing is going to be the script that handles the input from the player. So let's take a look at it. This is the movement input script. It is not too long, as you can see, it's really simple, and it has 4 variables. First, it has a reference to the transform of the pointer of the unit, which is those little white arrows we saw on the scene. Then it has a reference to the actual script that does the movement. This script just handles the input from the players. Then it has a float to set a minimum distance in which you need. This minimum distance allows us to be able to filter the input so that only valid inputs are processed. So we're going to see more about this variable ahead. And a sprite renderer, which are the actual white arrows that in our cursor, in our pointer, sorry. So this is the transform of the pointer, and this is the sprite of the pointer. So let's see. Now, for the actual functionality of the script, if it is an input script, the first thing we have to do is check for an input. In this case is fire1, which is set to the left mouse button. When we get a mouse click, the first thing we do is to cast a ray from the main camera in the direction of the mouse cursor with this line of code. Ray, we can declare a ray and do the function on the main camera screen point to ray, and taking the position, the mouse position of the direction of the ray. Then we need to declare a hit variable to get the information of the results of that ray cast. If it hits something, it comes into this conditional, into this if conditional, and the first thing we do is to check into this if conditional, The first thing we do is to check if the thing this ray collided with has the terrain tag associated to it. We can see in our scene that our terrain has the terrain tag. So let's move on. When we check that the ray we casted when we got the click did collide with the terrain, we then proceed to draw the white line you see in the scene edit window. Let me show you. This is just you see the white line, and at the end of the white line there is the pointer that lets us know where the unit is going to go, is going to move. See how the ray goes from the camera to the direction the mouse cursor is? Really good. So let's move on with this script. Okay, next thing. We need to get the position of that collision between the ray and the terrain. And we get that position in these two variables, the position on the x-axis and the position on the z-axis. Remember, heat is our variable that allows us to get information from that ray casting heat. In other words, the heat variable holds all the information that results from that ray casting hitting something in the scene. Much better. Okay, now we get the position in x, the position in z, and leave the y position of the pointer as it was. We don't need the information of the collision in the y-axis. And then we set that position to the pointer, which is those white arrows that let us know where the unit is going to be moving to. Now, one last conditional to verify that the click was a valid moving click. Maybe that sounds a little complicated, but it's not. And we want to see if the distance between this new position of the pointer and the position of the unit itself is greater than the minimum moving range we assigned through that float variable we had up here. This allows us to not process when the user clicks too close to the unit, so it's not necessary to move it. Let's see this in action. And there, maximize. See, if I click too close to the unit, it won't move. If I click outside the minimum distance to move, then I can move. If I click too close to the unit, it won't move. If I click far, then it will move. So then let's move on with the actual script that moves the unit. This is the script that actually does the movement of the unit. As you can see, it's really short. It only has 3 variables. The first variable is a boolean named moving, a reference to our navmesh agent, which is the component that allows the unit to use the navigation tools that Unity offers, and a reference to the transform of the pointer of that unit, the little white arrows. So, as you can see, we only have 2 instructions inside a conditional inside the update function. So when the variable moving is set to true, we set the destination of our navigation agent to the position of the pointer that we set with our ray casting from the camera, and the agent.resume resumes the movement of the navigation agent component. It is here just in case something happens or there's a sudden stop, or anyway, it's like a safety line of code. So when do we set this moving boolean to true? On the input script. On the input script, when we get a valid click, we set the moving variable to true, and that starts the movement of the unit, as you can see here. Let's see this. Here we have the moving variable. Let's say play, and when I click, I need to not maximize it. Here, pay close attention to the moving boolean here. If I click, it sets to true, and on the next script we are going to see when we turn that boolean to off, when we set that boolean to false. So let's see the fourth and last script of this system. This is the movement stop script. It has just 3 simple variables: First, a rotation speed that has nothing to do with the functionality of the script. A reference to the movement script that is on the unit we're going to be moving, and a reference to the sprite of the pointer of those white arrows. So, for the initialization of this script, the only thing it does is disabling the sprite of the white arrows, so they hide. We don't want to see the pointer always. We don't want to see it always. We only want to see the pointer when the unit is moving. On the update function of this script, this has nothing to do with the actual movement. This just rotates those little white arrows. The actual functionality of this script takes place in the trigger enter, which is a function that you can only do if the object that has this script has a trigger collider, which is here. The sphere collider is trigger, and here we can see the sprite render, which are the little white arrows. See? And here we have the move stop script. The rotation speed, as I said, is just to see the little arrows rotating, and it will only be visible when we want the unit to move. When something enters this collider, this trigger collider, this statement over here checks the tag of that object that enters the collider. If the tag is the same as the movement script, as the object that has the movement script that we previously assigned as a reference, you see this object. It comes here, it says whose object is this? Is this object. What tag does it have? Here 1. Yeah? So essentially this is the object that entered the collider, has the tag gear 1. I can actually comment this, show you what's happening here. If other dot tag equals gear 1, let me check if it has a space. No, it does not have a space, so this should work the same. Now, why I do that? Because then it's easier to give this component to other units, and of course the other units won't be this unit, won't be the unit number 1, it's going to be other unit. So only by assigning the reference moving script, the movement script, I can find the tag of the unit I want to stop. So when the unit enters the collider, then it evaluates if that unit was moving. If it was moving, it tells to stop. It sets the moving boolean of the moving script. You can see it here. It set it to false, so it won't evaluate this anymore. Set it to false, and this is when we hide the pointer, the white arrows. And that's it. That's everything you need to have to do a simple point-and-click movement system in Unity with the navigation components like the navigation agent and the navigation mesh. So that way it's the simplest way to have a real-time strategy like movement system where your units won't collide with obstacles and will pick the best path to whatever the place they are going to be moving to. So if you have any questions, leave them in the comments, and thanks for watching this video.